Okay, everybody, this snapshot video is in regards to Chebyshevs theorem and the empirical rule. Basically, these two properties associate an interval that is centered at the mean. Let me get my pen working here. So we have an interval, and it is centered at the mean, and it associates that interval with the percentage of data that's going to fall in that particular interval. Now, what's important here is to realize that we're going to have to understand that we need to look at the distance from the mean to an endpoint of that interval. So whatever the endpoints are, that distance from the mean to the endpoint is going to be represented by k times sigma, where sigma is the standard deviation. So k is the number of standard deviations. So both of these theorems really relate. The number of standard deviations you are within the mean and the percentage of data in the interval. So the first theorem is Chebyshevs theorem, and it says that the percentage of values for any data set that falls within k standard deviations of the mean will be at least 1 minus 1 over k squared. That is, Chebyshevs relates the percentage to this formula right here. 1 over 1 minus 1 over k squared, and k has to be greater than 1. But what is k? K is the number of standard deviations you are from the mean. That is an endpoint, okay? So here's one of the endpoints, and the other endpoint would be minus k sigma, all right, from the mean. So that's what we're going to be working with. So we could either be given the percentage and determine the interval, or we could be given an interval and determine the percentage. So we have two directions here. So we're going to look at the first example, okay? And our first examples are related to Chebyshevs theorem. And the difference between Chebyshevs and the empirical rule, basically one, the empirical rule requires the data to have a bell-shaped distribution. Two, the empirical rule is a table, and there are only three possible values we identify with for k, 1, 2, and 3. But we'll get to that later. We're going to work with Chebyshevs first. For our first example, the mean of a distribution is 20, and the standard deviation is 2. We want to answer the following question. What percentage of data values will fall between 10 and 30? So we are looking for the percentage of data that's going to be between 10 and 30. Now, if we notice that the mean here is 20, the distance from 20 to 30 is 10, and the distance from 20 to 10 is 10. That is, we have an interval. It is centered at the mean. We're trying to find the percentage of data in that interval. That suggests using Chebyshevs theorem. We don't know anything about the distribution, if it's bell-shaped or not. All right, so the relationship now is that percentage is equal to 1 minus 1 over k squared. What is k? Remember, k is the distance from the mean to the endpoint. Well, we know that distance. It's 10. So 10 is equal to k times sigma. K standard deviations from the mean. So that's what the distance is, k times sigma. I think I said it a little bit wrong there, but that's what it is, k times sigma. All right, well, we know what sigma is. Sigma is equal to 2. So we have this relationship, 10 is equal to 2 times k. Solving for k is equal to 5. So therefore, we can plug in 5 for k. 1 minus 1 over 5 squared is 25. So if you do your fraction math, this is 24 over 25. And as a percentage, I'll do the calculation here right quick. 24 divided by 25, 96%. So the answer to this problem is 96%. In our next example, we want to know the percentage of data values that fall between 12 and 28. So once again, we have a percentage of data being related to an interval that suggests either working with Chebyshevs or the empirical rule. We can't use an empirical rule because we haven't said anything about the distribution of the data. So let's take a picture of our interval. It's 12 and 28. Our mean is equal to 20. The distance from here to here is 8. Likewise, the distance from here to here is 8. So we are centered at the mean. We need that. Okay? Now, once again, the relationship from Chebyshevs is the percent is 1 minus 1 over k squared. The k is related to the distance from an endpoint to the mean by this formula here, k times sigma. We know sigma. Sigma is 2. So 8 is equal to 2k. So in this case, 4 is equal to k. So now we have k. We're going to plug it into the formula. 1 minus 1 over 16, which is 15 over 16. And 15 over 16 is equal to 15 divided by 16 is 93.75%. 93.75%. Alright, moving on. You can always stop the video and rework it, right? Alright. We now have a distribution of 160 data values that has a mean of 72 and at least 120 fall within the interval 67 to 77. What percentage of the values should fall in the interval 62 to 82? So this one's a little bit different here. What we know is that we have a distribution of 160 data values that have a mean of 72. And at least 120 fall in this interval here. So what do we know? In this interval, 67 to 77, here's our mean, 72. Our distance here is 5. Our distance here is 5. So we're centered at the mean. Well, guess what? What percentage of data is in this interval? 120 divided by 160. Or 120 divided by 160 is equal to 75%. So 75% of our data is in this interval. Chebyshevs Chebyshevs relates the percentage to this formula here. Right? Okay. Well, that's 0.75 is equal to 1 minus 1 over k squared. Solving for k squared, we get 1 over k squared. Alright, 1 over k squared. Fix that. It's 1 minus 0.75. So 1 over k squared is equal to 0.25. You can do the math. You've had algebra. So therefore, k squared is 1.25. So k is equal to 2. Show yourself that k is equal to 2. Now, if k is equal to 2, we know the relationship between the distance to an endpoint is equal to k times sigma. I now know k is equal to 2, so 5 over 2 has to be sigma. So now I have sigma here. That allows me to answer the question at hand. We want to know the percentage of data that lies between 62 and 82. Here's our mean. The distance from here to an endpoint now is 10. Likewise in this direction. So we know 10 is equal to k times sigma. The sigma is 5 over 2, correct? That's what we got from here. Solving for k, we get 20 over 5, so k here is equal to 4. So k is equal to 4, and so therefore, the percentage of data in this interval is 1 minus 1 over k squared. That's 1 minus 1 over 16, which is 15 over 16, which is as in the last problem there, 93.75%. So this was a bit trickier. This will not be on the exam, okay? But this helps you get to thinking how some of these problems can be figured out. All right, maybe for homework. But there you go. I used one piece of information to find the standard deviation, which then I was able to work with in the second part of the problem to figure out what K was going to equal to, because I didn't have the standard deviation. Moving on. The average number of calories in a regular sized bagel is 240. If the standard deviation is 38, find the range in which at least 75% of the data is going to lie in. So, I am looking for an interval that contains 75% of my data. I know the center of that interval is going to be the mean, which is 240. Okay? Now, I'm given the percentage here. Chebyshevs relates the percentage to this formula here, right? This allows me to solve for K. 1 over K squared is 1 minus 0.75. 1 over K squared is equal to 0.25. Once again, if you solve for K, show yourself you're going to get K equal to 2. Okay? And K is equal to 2. We know that the distance from here to here is K times sigma, right? So, K times sigma is equal to 38 times 2, and 38 times 2 is 76. So 2 times 16, 76. So K times sigma is 76. So we're going to add 76 to 240, and we're going to subtract 76 from 240. Alright, so that's what we're going to do next. Okay, when you subtract, you get 164. When you add, you get 316. So here's the interval that contains 75% of my data. Okay? Moving on. Americans spend an average of 3 hours per day online. If the standard deviation is 32 minutes, what is the range that will contain at least 88.89% of the data? So, once again, I am looking for an interval that contains a certain percentage of my data. That suggests Chebyshevs theorem, so I know it's going to be centered at the mean, which is 3. The relationship between the percentage and that distance is given by 88.89%, which is 0.8889. That's got to be equal to 1 minus 1 over K squared, correct? Solve for 1 over K squared. I get 0.1111. Flipping, K squared is equal to 1 over 0.1111. So when I flip that, I get something like 9.0009, taking the square root, and I get this is approximately equal to 3. So we're going to just approximate, well, it's 3.00015, and, well, that 3 would be close enough, but I like to keep 4 places, so I'm going to work with 3.0002. So that's what K is equal to. Remember, the distance here is K times sigma. So K times sigma would be, sigma here is 32. And I get 96.0048. I'll make sure That's 3.2. It says 32. Oh, I got it. 32 minutes. Tricky problem. That's 32 minutes. I'm working with hours here. So I got to divide 96 by 60. I knew something was wrong there. That was just too big of a number. I have to divide by 60 because I'm working with minutes here. So once I divide by 60, I get 1.6008 hours, rounding off. That's what it is. So I'm going to add that to my 3, and I'm going to subtract it from 3. So my interval is going to be 3 plus this number, and 3 minus the number. Okay? So 3 plus the number is 4.6008. Again, if you round it to 4.6, I would take that. And subtracting from 3, I get 1.3999. Okay? That's what I get. Alright? There you go. Now I'm going to stop the video. I'm going to have another video associated with the empirical rule here. Alright? So there's 2 video buttons on this worksheet. Alright?